When we look at galaxies, we see they spin far too fast to stay together. We assume there is invisible mass providing the gravity to hold them. We call it dark matter, yet decades of searching have found nothing. When we look at the early universe, matter and antimatter should have canceled each other out perfectly. Instead, a tiny fraction of matter survived. This is baryogenesis, an imbalance we have no physical reason for. When we measure the energy of empty space, we find a cosmological constant that is fine-tuned to 123 decimal places. And when stars collapse into black holes, the laws of quantum mechanics suggest data is destroyed forever, which would break the underlying logic of physics. Standard cosmology treats these as 4 disconnected problems. To fix them, we invent 4 separate patches: new particles, new forces, and new fields for every new observation. Unified dynamics identifies these crises as different projections of one singular geometric event. Looking at the fundamental substrate of reality reveals that these observations are inevitable consequences of the universe's internal grammar. In the unified dynamics framework, the early universe begins as a hot, chaotic grid of geometric shapes, called an iterated function system lattice. It lacks any defined order. As the universe expanded, it cooled. Once the ambient energy dropped to roughly 249 kiloelectron volts, it hit a critical threshold. This was the Z2 framing transition. The chaotic lattice aligned into a rigid, perfectly tetrahedral grid, snapping into place much like cooling iron becomes magnetic. This snap left behind specific geometric defects, the rebel of a phase transition that provides the origin for the particles and forces we see today. Dark matter is the first piece of rebel from that freeze. During cooling, 4 nodes lock together. Positive and negative states cancel, leaving a perfectly neutral gauge singlet. Invisible to electromagnetism, it interacts only through gravity. Derived from the fixed geometry of the tetrahedral seed, this dark matter relic weighs exactly 2.04 mega-electronvolts. The second artifact is the imbalance of matter and antimatter. The freeze was a process biased by the shape of the tetrahedron itself. This diagram reveals the lattice seed's internal geometry, an inherent 60-degree bias. During the freeze, this angle acted as a phase bias, causing matter domains to nucleate and grow slightly faster than antimatter, locking in a population surplus before the transition completed. The invisible dark matter and the excess of visible matter we observe are both structural features of how this tetrahedral grid folds under a temperature drop. The third artifact is the cosmological constant. During the snap, microscopic regions of the grid were trapped in the Muon orientation. Standard physics assumes these defects would radiate a massive, universe-breaking amount of energy into the vacuum. Applying fractal geometry, the lattice physically screens trapped defect energy at each recursive layer. Every layer filters energy by a fixed ratio of 7 to 192. After 19 levels, this fractal screening drops the vacuum energy to the measured 10 to the negative 123 scale. Then there is the matter of black holes. Information moves across this ordered grid in 5-component packets called carriers. In this framework, the local transport of carriers across the lattice strictly conserves data. It cannot be destroyed by a gravitational collapse. Because data cannot be deleted at the event horizon, it inevitably leaks back out through the entanglement of carrier packets. The expanding vacuum and black hole event horizons emerge as predictable, inevitable behaviors of this strictly conserved fractal network. A single topological cooling event has provided the physical origin for 4 massive cosmological observations. This system requires 0 free parameters. There are no invented particles and no arbitrary math, only the topological rules of a tetrahedron. For decades, we have been patching our equations to make them match the observations of the stars. The universe simply followed the geometric rules available as it cooled, locking into an elegant origami structure governed by the symmetry of the tetrahedron.